Got short sheet. Okay. So we know we can change chemicals in moles. We can go from moles of one chemical to moles of a different chemical as long as we have a balanced equation. Okay, but we can't measure moles. So what good does it do us? If we can't measure moles, what can we do? Well, what can we measure? We could measure grams and then change that into moles. We've learned how to do that already. Right? And where do we get the numbers for changing grams into moles? It's our periodic molar mass off that periodic table, right? Then once I get moles, then I got a conversion factor where I can change chemicals. And I'm going to get those conversion factors from the balanced equation. And then once I get those, I'll be able to turn those back into grams again. Because when I'm trying to say how much I'm going to make, I don't want to know how many moles I'm going to make. I want to know how much it's going to weigh. And I'm going to get those numbers off the periodic table. So the whole map of how you're going to do these problems looks a bit like this. If I give you grams of A, the first thing you're going to do is change grams of A into moles of A. And you're going to get that number off the periodic table. Then you're going to take the moles of A and turn it into moles of something else. And you're going to get that number from the balanced equation. And then you can take those moles of B and turn it into grams of B, getting the number off the periodic table. Now that's if they give you grams and ask for grams. If they give you moles of one reactant and ask you grams of another reactant, you'd skip the first step. If they only ask you how many moles of product you make, you don't have to do the last step. So the units will tell you where to start this. If they give you grams, you got to use the periodic table. If they give you moles, you're ready to change chemicals. If they ask you for grams, you're going to need the periodic table. If they ask you for moles, then you could just use the balanced. You stop at the balanced equation. So at most you would do 3 conversion factors. At most you do 3. Last night or last Friday, whichever one you decided to do, you just did these 2. Right? You just did 1 conversion factor where you got the number out of the balanced equation. So we just got to tag numbers off to each end of that. So here's our acetylene reaction again. Calculators and periodic tables will be your friend, unless you're really good at math in your head and have a fantastic memory. I'm getting out a calculator. So we'll use this reaction for a couple of examples. Okay. But I wanted to make 8.95 grams of water. How many moles of C2H2 would I need? So I start off with the 8.95 grams of water. I don't have much choice about what to do here. What can I turn grams into? Can I turn grams of water into into moles of C2H2? No, but I can turn grams of water into moles of water. So I'm going to take the grams of water and turn it into moles of water. Just to remind you what the math looks like. I've got two H's and one O. H is 1.01 grams on the periodic table. O is 16.00 grams. So that's 2.02 grams of hydrogen and 18.00 grams of oxygen. I'm sorry, 16.00 grams. When I add that up, it adds up to 18.02 grams for water. So that 18.02 grams, I just figured out, is 18.02 grams is how much 1 mole weighs. And that cancels out grams of water. Now I want to get rid of moles of water. What can I turn moles of water into? Well, the whole reason to change into moles is so you can change chemicals. So the chemical they asked me about was C2H2. And the number in front of C2H2 is a 2, my balanced equation. The number in front of H2O was a 2. And now I got rid of moles of H2O and I've got the units they asked for, so I stop. I could have gone to grams, but they didn't ask me for grams. So I can stop right there and just push buttons. So 8.95 divided by 18.02. I'm not pushing times 2 divided by 2. With 3 sig figs is 0.497 moles of C2H2. So we've done this part before. We've done this part before, and we learned this part last night. Or last Friday. All we're doing is putting those two pieces together. So it's actually nothing new, just putting pieces together that we've done before. It's okay? Same reaction. If 2.47 moles of C2H2 are burned, how many grams of CO2 are formed? Will not let me write a decimal point there. It's just bizarre. So 2.47 moles of C2H2. Want to get rid of moles of C2H2? What do I turn that into? Well, I could turn it into grams of C2H2. Would that get me closer to my answer? So the whole reason we go to moles is so we can change chemicals. The chemical I want to know about is not C2H2, I want to know about CO2. And when they're both moles, I can get the numbers out of the balanced equation. There's a 4 in front of CO2 and a 2 in front of C2H2. Now I want to get rid of moles of CO2, and they ask for grams of CO2. And 1 mole is 1 carbon times 12.01 grams is 12.01 grams. 4, there are 2 oxygens times 16.00 grams is 32.00 grams. That adds up to 44.01 grams altogether. And that's how many grams in 1 mole. Notice I still use 1 mole even though the equation's got 4 in front of CO2. Because that 4 is how many molecules react with 2 molecules of C2H2. 1 mole weighs the number off the periodic table. So if you're going to use the number off the periodic table, that's how much 1 mole weighs. Thing on the top, thing on the bottom have to be the same size. Push the buttons. 2.47 times 4 divided by 2 times 44.01. And with 3 sig figs, I get 217 grams of CO2 because that's what my units work out to be. Extra tough. Okay. These took 2 conversion factors because one of them started at moles, the other one ended at moles. And then you get the nasty question, which is like the one they asked in the bell work. But it's a trick question. You say, well, what do you mean it's a trick question? Well, if you tried to write that equation, you'd say Fe will replace copper. The Fe will end up next to sulfate. The copper will end up by itself. Okay. Nope, we get Fe next to SO4 and Cu by itself. So I get copper. The problem is when I go to write formulas, SO4 is 2 minus, what's the charge on iron? We don't know. So I have to give the equation, or I have to tell you it makes the iron 3 ion. It did make the iron 3 ion. There's my equation. Iron plus copper 2 sulfate makes, that's iron 3 sulfate and copper. But that doesn't do me much good unless the equation is balanced. So to balance it, I got 2 Fe's, so I got to put a 2 in front of Fe. I got 3 SO4s, so I got to put a 3 in front of CuSO4, which gives me 3 Cus. So I put a 3 over there. Hey, I got it right. Sweet. Hey, now I can take the 10.1 grams of Fe. Now, what unit do I want to get rid of? Well, grams of Fe. Where's it got to go? On the bottom. What can I turn grams of Fe into? I can turn grams of Fe into moles of Fe. And that cancels out grams of Fe. Now that I got moles, I can change chemicals. So I'm going to go from moles of Fe into moles of what they asked for, and they asked for copper. So 2 moles of copper for every 3 moles of, 3 moles of copper for every 2 moles of iron. And that cancels out my moles of iron. Now I need to get rid of moles of copper. And moles of copper, I can change into grams of copper, because 1 mole of copper weighs 63.55 grams. That's what it says on the periodic table. And you got your calculator, push all the buttons. 10.1 divided by 55.85 times 3 divided by 2 times 63.55. 3 sig figs in the 10.1, 4 in the 55.85. unlimited in the 3 and the 2. And 4 in my 63.55, so my answer can have 3 sig figs. And that works out to be 17.2 grams of copper. So that's all I got for today. So the way to get better at this is to watch Mr. Green do it. No. The way to do it is to practice